All right, we're back. So we're on number 6. We're going to name the rays in this figure right here. Okay, so how do you name a ray? Well, to have a ray, you have to start at an endpoint, and then you have to, from the endpoint, you have to see if I follow the shape, which in this case is a line, one way or the other, will it continue and go through any points? Okay, so let's start at A right here. All right, so if I start at point A and I went down to the left right here, you can see starting at A, going down this way, it doesn't go through any points, so there's no ray to be named. But if I start at A and I go up this way, you could see that it goes through B, it also goes through C, and I could also go through D. So 3 rays that I could name starting at A is, I could name ray AB, or I could name ray AC, or I could name ray AD. Okay, so that would be 3 rays that I could start at point A. Now I go to point B, and I do the same thing. So if I started at point B, and here's point B, and if I followed this ray going down to the left, you could see that it goes through an A, and it keeps going. So starting at point B, I could have point or ray BA. Now if I go the other way, if I go back to B and I go this way, you could see that if I started at B, that would be my endpoint. I could follow the ray in this direction through C. I could follow it through D. So 2 other rays I could write that start at B would be BC and ray BD. All right, now let's go to point C. So if I use C as my endpoint and I went down to the left, you could see I could draw a ray that starts at endpoint C. It goes through B, it also goes through A. So I could have ray CB, and I could also have ray CA. Okay? Now if I went back to C and used it as an endpoint, but I went the other direction, you could see that I go through point D. So I also have ray CD. All right, now I have one more endpoint that I could use, and I could use endpoint D. Okay, so if I started at D, I can't go to the right up this way because there's no points it goes through. However, if I started at D, you could see I could draw a ray that continues through C, B, and A. So 3 more rays that I could draw would be ray DC, ray DB, and ray DA. And when you name a ray, you want to put that symbol on top of the letters to signify that it's a ray. Number 7A, name the pairs of opposite rays with endpoint C. Okay, so what I'm doing is I'm starting here at C, and remember, opposite rays are rays that go in complete opposite directions and they make a line. So if I started at C, I could go this way through D. So one of my rays would be CD. And the opposite ray of that would mean I'd start at C, but instead of going this direction up to the right, I'd go down this way. And you can see if I started at C, I could go through B or A. So I could call it ray CB, or I could call it ray CA. Okay? Number 7B, name another pair of opposite rays. So what I would do is to name another pair of opposite rays, I would now go to point B and use point B as an endpoint. So I could start at point B, go down through A, so I could have ray BA, and opposite of ray BA would mean I would go back to point B, but instead of going to the left, I'd go up to the right. And you can see starting at B, I could go through C or D. So opposite would be ray BC, or I could say ray BD. All right. Now, number 8 through 12, what we're doing is we wanted to determine whether each statement is always true, sometimes true, or never true. So I read the statement, and the first thing I want to do is I want to determine if it can happen. So plane ABC and plane DEF are the same plane. So I ask myself, is it possible for me to have A, B, C, D, E, and F all on the same plane? Okay, and it is, and would be possible. So if I just put all the points A, B, C, D, E, and F, they could all be on the same plane. So we know the answer is not never. All right, so we know it's going to be always or sometimes. Now we ask ourselves Or is it possible that I could put ABC on one plane and DEF on a completely different plane? And you could see I can right here. So plane ABC and DEF are on the same plane. It could look like that, or it could look like that. So the answer is, to number 8, it's going to be sometimes. Number 9, line DE and line DF are the same line. Okay, so we ask ourselves, if I have just one line, can I have a line where D and E and F are all on the same line? Yes, you can. So we know it's not never. So we know the answer is always or sometimes. But now the question is, can I have a line that is considered line DE, and can I have a totally different line that would be considered DF? And I can. So the answer is sometimes. Number 10, plane XYZ does not contain point Z. Okay, so this is saying, is it possible to draw a plane and it's called XYZ, okay, but Z can't be on the plane. So Z has to be out here somewhere. Well, Z's out there, we can't call it XYZ. So this can never happen. Number 10 is never. Number 11, all the points of a line are coplanar. Okay, so what this is saying is, can you have a plane? Coplanar means on the same plane. Can you have a line on that plane where every single point on that line is coplanar? Yeah, you can. You can see every single point is on that line and every single point is on the plane. So we know the answer is not never. Okay, but that means it's always or it's sometimes. Or here's the other possibility though. So is it possible to have a line where the line pierces through the plane? So you can see that drawing right there is showing my line pierces through the plane. So as you can see, every point right now, every point is on the line, but is every point on the plane? The answer is no. Some of these points are below the plane. Some of them are above the plane. So number 11 is sometimes all points of a line are coplanar, but sometimes it's not. Okay, last one, number 12, two rays that share an endpoint form a line. Okay, so this is saying I have a ray, and then I have another ray, and they both share the same endpoint. Well, so you can see they can form a line. Okay, so we know the answer is not never. However, is it possible to have a ray and to have another ray? Look, they both share the same endpoint. Do those form a line? No. So number 12 is sometimes. Okay, so that's the way you have to go about those problems. Moving it over to the other side. This problem says, name the intersection of each pair of planes. To start, identify the points that both planes contain. Okay, so in number 13, we're talking about plane DCG. So I find D, I find C, I find G. So that's going to be this plane on the right here. Okay, and plane EFG. So where's E at? I have E, I have F, and I have G. That's the bottom plane. So I'm comparing where does the bottom plane and where does the plane on the right of this cube or this box come together. Well, they come together at point H and they come together at point G. And then it's every point in between H and G that the two planes share. So everything in between H and G, and it's going to be a line. Why is it going to be a line? Because planes, remember, are continuous. So that means it's going to be a line that's continuous. Number 14, I want to find plane EFG. So EFG, so that's the bottom of the shape. And plane ADH, so there's A, there's D, that's H, so that's going to be the front of the shape. So what points does the front of the shape and the bottom of the shape share? Well, they share points EH. So that means they share everything in between E and H. So we know the answer is E and H, and we know it's going to be a line because planes continue forever. 15, we want to figure out where does plane BCG and ABF intersect. So there's B, there's C, there's G. So plane BCG, and I can color this one because this is the last problem I'm going to do. It's this back plane here. Okay, and then I have plane ABF, ABF. So that is the plane over here on the left. So where does the back and where does that left, what do they share? Well, they share point B and they share point F. So that means they share everything in between B and F. Okay, so that means their intersection is going to be line BF. Okay, so number 15 through 18, we're going to name two planes that intersect in the given line. To start, identify the planes that contain the line. So in number 16, we're still using this figure. So we're talking about line CD. So there's line CD. So what two planes have line CD in them? Okay, well, we've got this plane right here, okay, which is CDHG. We only have to use 3 letters, so I'm going to say CDH. And line CD is also part of the top of the shape. So that would be CDAB. So I'm going to say CDA. Remember, you only have to use 3 letters to name a plane. Okay, number 17, I'll use pencil for this one so we can see it. So what two planes intersect at line DH? So here's D, there's H, I color that in. So I'm looking for what two planes intersect that line. Well, it's this plane right here and the plane in the front. So how do I name this plane? D, H, and then a third letter. I could use G or C. So how about DHG? So plane DHG, and the other plane that has line DH on it is going to be this plane right here. So that would be DH, and then I could use E or A. So how about DHE? So those could be two planes that we have that intersect at line DH. Last one, number 18. So now we want to find the two planes that intersect at line EF. There's EF right there. Okay, so what planes contain that line? Well, we've got the bottom plane, which would be the letters F, E, H, and G. I picked 3 of those, E, F, G. Okay, and the other plane that contains EF is this plane over here on the left of the box. So that's EF, B, and A. So I picked 3 of those letters, E, F, B, I'll choose. So those are the two planes, okay, that intersect. All right, number 19 and 20, we're going to copy the figure. So we're going to copy this figure right here. And then what we're going to do after we copy the figure, we're going to shade the plane that contains the given points. Okay, so here's my figure. I'm drawing a 3-dimensional figure here. I'm going to put the letters in. So I have, let's see, A, B, C, D on the top. A, B, C, D on the top. Then I have G and H down here. And then I have E and F. Okay, so now I'm trying to find which, I'm going to shade the plane that contains the points A, B, and C. Here's A, there's B, and there's C. Well, that's the top plane. So that would be number 19. Okay, number 20, I'm going to draw the figure again. And then I'm going to identify the 3 points that it gives me, which would be C and D and H. And then I'm going to shade in the plane that contains points C and D and H. Okay, so once again, I've got A, I've got B, I've got C, I've got D, I've got G, I've got H, I've got E, I've got F. So point C is here, point D is here, point H is here. So what plane is that? Well, it's going to be that plane right there. So that's the plane that contains points A, C and D and H. Okay? All right, last 4 problems. This says that postulates 1 through 4 states that any 3 non-collinear points lie in one plane. Find the plane that contains the first 3 points listed, then determine whether the 4th point is in that plane. We're going to write coplanar or non-coplanar. Okay, so basically what we have going on here is we have a plane that's going this way, and I'm outlining it in blue, and then we have another plane that's going up and down, and I'm outlining it in red. Okay, and the way that this problem works is that the first 3 points, so P, T, and R in number 21, P, T, and R are on a plane, and you can see they're on the blue plane, and then you're trying to determine if the 4th point is on that same plane. So N. So is N on the blue plane, which is what P, T, and R are on? It is. Remember, if it's on the border of the plane, the line of the plane, it's on the plane. So N is on the same plane, so in number 21, we're going to say the answer is coplanar. Why coplanar? Because they're all on the same plane. Okay, number 22, we have P, O, and S. Those are my first 3 points. So P, O, S. So those 3 are in the red plane here. Is point N also in the red plane? It is, because it's right on the red border there. So number 22 is coplanar as well. Okay, number 23, my first 3 points are T, R, and N. So T is here, that's in the blue. R is in the blue, N is in the blue. So then we're determining, is this 4th point, is point U also in the blue plane? This plane here, it is not. Okay, so we would call these points non-coplanar. And then the last one, my first 3 points are point P, O, and R. So there's P, there's O, there's R. So they're on this blue plane here. So the 4th point, S, is it also on the blue plane? It is not. S is in the red plane. So 24 would be non-coplanar as well. Okay, guys? If you have any more questions, feel free to ask in class. Other than that, do the best that you can. Talk to you later.